you reminded me. That's very, very good. Appreciated. So let's try one more problem here, like problem, I just want to look at, say, number 18. If people recognize a brand. I think these exercises are nicely illustrating that statistics could be utilized just about for anything. So I'm on the page 144, as you can see up here, and it says that person selected, and out of 831 consumers, 18 did not recognize the brand of Campbell soup. So out of 831, 18 did not know this brand. So the question again is probability that consumer will recognize. So now we need to be a little bit more careful. So you found the probability that someone did not recognize. So you can say recognize, remember, with a bar, right? Did not recognize. And then that if you take 18 out of this total 831, and if you use a calculator to divide this, you will get the answer, which is some decimal. Let me double check. 18 I divide by 831, and then that looks like about 2% or something like that, a chance that someone is not recognizing this brand. But now when I look at the question of this exercise, they say, what's the probability that consumer actually will be in the opposite group of people, that the consumer will actually recognize it? So probability to actually recognize will be remaining people, right? So the remaining people probably recognized it. So how many remained? One can say, Alex, 800 and something. Yeah, I think 813, right? So what we need to do is just get 813 out of 831, and this will be about the remaining 90 something percent. We just, to be precise, put this in a calculator, of course. So it's 813 divided by 831. So this is about 98% approximately. I can say about 98% if I round it to nearest percent. I say, well, so Alex, we didn't really need to calculate that first piece. Well, technically not, but I think it's a very good idea to calculate it, because now I'm going to introduce you one very useful statistical formula here that actually says that probability of not recognizing is the same as 1 minus probability of recognizing. So the way to write that not are, they put it with a bar above in this textbook. So if something doesn't happen, then if I know probability that it does happen, or the opposite, so if I subtract from 1, probability of R, which is 98%, notice I get the remaining 2%, the one that we just had here. So it turns out that you can get the answer for these exercises 2 different ways. You can either go directly and answer their question. So how many people recognize it? So just see how many, 813. But you could also approach it from the perspective of the complement. And that turns out to be a very useful idea for later exercises in these sections. And that actually opens us doors to the next section. So it turns out I don't want you to do problems that deal with so-called odds. So these exercises, we usually skip, we're not using them. And so you just stop at problem 23. So this last page of section 3.2, you don't have to worry about. And then beyond the basics, all that stuff we don't really care for. But here comes a very interesting and useful formula for the probabilities. And it's called complementary events, or the opposites. And here's the formula that I was talking about that says probability of not A or A complement is 1 minus probability of A. So this is what we just justified. And that's what I want to practice on using in the next group of exercises. So let me try problem like number 3 here. So now I'm in the next section. I'm in the section 3.3, and I'm going to do exercise number 3. And in this section, we're going to utilize the formula above. So let us try to look at part A here. That says if P of A is equal to 5% or 0.05. What is the probability of not A, or A with this bar, which is called the complement or opposite to event A? Well, right away I can use the formula, so I can subtract from number 1 this probability of A, and since it's 5%, then the opposite will be remaining 95%, and we got the answer. So turns out the complements or the opposites always compose 100% with your original probabilities. So that's why you can subtract from 1 and get the complement. So let's try part B here. This says that based on the census, the woman of age 25 is selected and has 0.218 probability that she has a bachelor's degree. So probability to have a bachelor's degree, I can call it, say, let's say B, is 0.218. So this is our start. So the question is, what's the probability that she does not have bachelor's degree? So not B, right? Or B complement, B with that bar above. And analogously, we just subtract from 1 probability of B, which is a 0.218. And whatever comes out will be our answer. Looks like it's 782, and that's the result. So if about 21% of women have that, then remaining, or 78 something percent, do not have that. And that's not surprising. So they're opposites. So the complements or the opposites is what they're talking about. So I think that's a nice and intuitive formula. So maybe today, later today, I'll give you a quiz so you can enjoy using it. And I'd like to see what else this section has. And looks like exercise set from 9 to 12 will actually tell us this. So I want to look at exercises related to this little table here. And that table talks about Titanic passengers. And then they say, what's probability a woman or a child? So let's see what is actually going on in this group of exercises. Looks like there are some survived people and some people that actually died. And if they're talking about probabilities, we need to know the fractions, right? So if I need to get a probability, I must get the total number of these passengers. So let me find the totals for all of these. So I'm going to be adding these numbers together. So I produce totals here. So it looks like this will be like 9, and then 3 and 3 is 6, and there is 1. So it's 1, 6, 9, 2. For the next one, I get a 12, and this is 2, and this is 4, right? And then next group will be something like 4, and this is 6. And finally, for the last group, I have 45, right? So if I want to know the grand total, so if I add all of these, then I definitely want to use a calculator. So let me add these numbers together. 1692 with 422. Please double check. And 64 and 45, right? Plus 45. So this is going to be my total, which happens to be 2233. Oh no, 2223. 2223. So let me write this down so we don't forget that. 2223. So this is my grand total for the whole sample considered. So problem number 9 is asking about probabilities. So I'm probably going to have to use this grand total. So let us see what they want. In exercise number 9, they say find the probability that we got someone who is a woman or child. So what they're talking about is a group of passengers on that Titanic, and it seems that women and children are right here. All this part highlighted in yellow, so it's going to be either woman or child, and child means either boy or girl, right? So it looks like we have out of grand total 2223, how many women, children were all together? So it looks like I need to put this 422 women together with 64 boys and also with 45 girls. So we got this 45 added all together. So why don't I, again, put this all in the calculator? Because otherwise, how would you add them? You will have to divide this eventually anyways, right? And do division in your mind is not probably the best thing to perform. So let me just put this all in the calculator. So I will put parentheses around numerator, 422 plus, try to get a calculator and also calculate, right? So I put parentheses with numerator that I want to entirely divide by 2223. So we get some answer, which is point, let me write it, 2388, whatever this means. So you can see about 24% were women and children on that Titanic. That's exercise number 9. So please notice that they ask us about such thing as one or the other. So I put it all together. I highlighted it all in yellow so we can better see what is that they talking about. So how about the second probability equation, exercise 10, that says find a man or someone who survived the sinking. So now I want to find the probability of men or someone who survived. So what are they talking about now? So I guess this yellow I'm not gonna highlight anymore. And I'm gonna look at the probability of all men, which is right here, or those that survived. It looks like those that survived present in the first row in this table, right? So as usual, probability is a fraction. So first of all, I'm gonna put down my denominator. We already know it's 2, 2, 2, 3. So now how can I go about these numbers? Well, looks like I'm gonna start with a probability of men, which is 332 and 1360. Or you're right, it could be 1692. And then you go with the other 3 more categories. And there are 318, and then for boys and for girls. So looks like you did it so fast. That's impressive. So that's 29 and also 27. So all of these little numbers were added together. And again, I should put parentheses, make sure that I get the answer correctly. And now we can actually go ahead and calculate. So please notice if I highlight the portion of my table that corresponds to it, well, then it all looks pretty straightforward. So let me get all that entered here. 3, 2 plus 1360. We already know that this is actually 60, that it is actually 1692 plus 318 and so forth. So it looks like we have quite standard setting, although fraction, when you say it looks nasty. Yeah, it doesn't look like a very attractive fraction, but the calculator doesn't care. And we've got the answer, and this answer is here. It's about 0.929 ... right? 929 ... So we got ourselves another nice little answer. So I want you to notice that the exercises here may not be as straightforward because you want to, well, do a little bit of a preparation. Every time you do the problem, you want to prepare some pictures, so it starts to make a little bit more sense. So let me do one more, exercise 11, and then you can try one. So in exercise 11, again, they want to find the probability of getting a child or someone who survived. So it looks like now they still care, let me write it down, probability that they have a child or someone who survived. So it's kind of similar to the previous case, but not men here, but now we need a child, so we take all of the boys and girls. So once again, it looks like we are to produce fraction, and we know denominator for this fraction, right? It's now 2, 2, 2, 3 all the time, the same thing. So that was a good idea to find. So now we need to get a child or survived. So it looks like there are a bunch of numbers here to add. So I can just start with 3, 3, 2. So everything that is highlighted in this violet color, 318, right? So once you highlight it in your table, then it becomes pretty straightforward. So I can go with the entire first row, 29 and 27, so I don't miss any. And then add 2 more entries to it, 35 and 18. So no matter how you start adding these numbers, the answer will be the same. And looks like we probably started to get the idea here, how all of this is being solved. Make a picture. Picture helps. So let's do this. 332 plus 318, right? More numbers here. 29, 27, 27, and 35 and 18, and two more, only two more. Is it? I already entered all of them. Oh, I guess I got carried away. I like entering them, I guess, that's why. So anyways, divide this by 2, 2, 2, 3, and we're done, about 34%. So we find various little probabilities. What for? Well, they usually ask you what the chance for this or for that to happen. So we give them the answer. Basically, that's about it. So I'd like to return back to the story of my complements, because turns out this is fun stuff to do. We'll do more of problems in this section, of course, with tables. But I want to return back to maybe exercise 4, which is very, very similar to exercise number 3 that I just done here on the left. So I would like to do one part of it, and then you can do another part of it. So I can do, I guess, a simpler part, actually more challenging part. Yeah, that's not going to be fair if I do the simpler part, right? So let me do part B of exercise 4, and then you can try to do part A of the same exercise and give me the answer, as usual, in this chat. So part B of exercise 4 says, if 61% of Americans, so if probability that someone believes, so put B, is 61%, well, we put it as 0.61, right? Always turn to decimals. That there is a life somewhere else. What's the probability that somebody does not share this belief, or what's the probability of B with a bar, right? What's the probability of B complement here? And it's 1 minus P of B. So the idea is the formula above, it doesn't matter whether you have letter R or B or A, it's 1 minus that probability, and I get the answer 0.39. So please do part A for the quiz for today. It is very, very similar question. So find P of A complement, please, and then put it here in the chat. And that's all you need to do for today. So I'm gonna stop to record, and you should not hurry. Please do it carefully, do it right. And that's